All right, we're going to sketch this behemoth, but first thing I'm going to do is I'm just going to rewrite it. So I'm going to write out y equals 3x to the 8th times x minus 5 to the 4th, and then I notice this 4 minus x squared, and I want to turn that around. So what happens is when you have a factor and it's backwards and it's subtract, you can turn it around by factoring out a -1. Because this is squared, it doesn't actually do anything because when you square a negative, it stays positive. But this next one, 3 minus x to the power of 3, I want to turn this around as well. When I factor out the negative to make that x minus 3, because it's cubed, when you cube a negative, it makes another negative. So I'm just going to take that negative and stick it onto the 3 at the front. So instead of being 3x to the 8th, now it's negative 3x to the 8th. And everything's ready to go. So my single roots, there's just 1 or single 0, and that's at -5. The bounces or even zeros are anywhere there's a power of that's even. So x to the 8th is at 0, +5, +4, and -3. The chairs or odd zeros are at 3 and 1. And now I'm just going to plot all those points. Boy, I'm slow. Okay, there we go. All the points are plotted, and the -3 at the front, that reminds me I'm going to end down. So I'm going to start in quadrant 4 and work this backwards. So I'm going to come up, and it's going to bounce on the blue, chair on the green, and I'm going to work all my way across. There's another bounce, bounce, and then pass through on the black, and there's my graph. Okay, this one's supposed to be just kind of fun because it's so big, but what's really important is that 4 minus x, and that you can turn it around to x minus 4. Because it's a power of 2, it does nothing to the equation, but the 3 minus x, if it's got an odd power, it's going to change the sign of the leading coefficient. So the leading coefficient was 3 for this polynomial function, but became -3 when we changed the order of 3 minus x.